So now that we've looked at geometric sequences, we're going to look at summing a geometric sequence. So again, adding up a total of them. And with arithmetic sequences, there's just partial sums where we add up any number of terms, like all the terms between 1 and 20, for instance. But we would never add up an infinite sequence. In geometric sequences, we have the option to add up both a partial sum, where we just go by a set number of terms. So, as example, from 1 to 20, or add first 20 terms. So there's a limit to it, it's limited. And the reason why is that if your numbers continue to get bigger each time, if we tried to add an infinite number of them, they would just become a large, infinitely large number. But in the case that we have infinite sums, we can actually add up every single number in the sequence out to infinity in a way. And the reason we're allowed to do that is only if your r is actually less than 1. So only if r less than 1. So examples of that could be r is equal to 0.75, r is equal to negative 0.5. And I guess instead of maybe saying less than 1, we should say between, well, maybe we should write it this way. Negative 1 works, but, I mean, less than 1 works, but really it's anything between negative 1 and 1. Anything between negative 1 and 1. Because we can take r values that are less than 1 down to 0, but we can also take r values that are between negative 1 and 0. So really anything from negative 1 to 1 will work. Another example there would be r is equal to 0.33 or something. So the reason we can do this is because when you have an r that's between negative 1 and 1, the sequence continues to get smaller. You get smaller and smaller and smaller numbers. So those get closer and closer to 0, and adding up a bunch of zeros doesn't change your sum. So the first one we're going to look at is our partial sums. So you can do this for anything, even for r's that are small. But keep in mind that you've got a limit here. You can only do an infinite sequence if r is between negative 1 and 1. Okay? So looking at partial geometric sequences, let's give a go. First thing I want to find is the common ratio between the terms. Again, this is what I'm timesing or dividing by between all of them. And you might be able to recognize it just by looking at them. To go from 40 to 20 to 10 to 5, you'll notice both of these, all of these, I'm dividing by 2. But I want to be able to think about what that is as a multiplication. So if you notice that it's dividing by 2, I wouldn't want to figure out what the divide is. I need to figure out what I'm timesing by. So I'm going to use that trick of taking the second term and dividing it by the first. 20 divided by 40 equals 0.5, or 1/2. Again, because dividing by 2 and timesing by half are the same thing. So r is going to equal 0.5. Next thing that I'm going to do is find my first term in the sequence, which in this case is equal to 40. And if we look at our formula up above, we just need a, r, and n. So n that we're looking for is find the sum of 20 terms. So we want the first 20 terms. That tells me that n is equal to 20. So plugging into my formula, the sum of the first 20 terms, which is why I'm putting the 20 there, the little 20 there, is going to be a, which is 40, times bracket r, which is 0.5, to the power of n, which is 20, minus 1. Now you'll notice it's not n minus 1 all up above as a power. It's actually just the power of 20 and then minus 1, unlike the earlier formula. And all of that's going to be divided by bracket r, which is 0.5, minus 1. So if you plug this into your formula into the calculator carefully, we can get what the sum is. And here we get the sum of the first 20 terms is equal to 79.999. I wouldn't round it too much here, because you want to show that it's not quite 80 yet. So It's not that big of a number, but you'll notice why is part of it's because each of these is getting smaller and smaller and smaller, so I'm keep adding smaller numbers on. So you can imagine the 20th term is a really tiny number. So just be careful, make sure that you get that into your calculator correctly, so double check it for yourself. If you're ready to go on, go on. If you want one more example, feel free to watch one more. Find the sum for the first 20 terms here. So again, 20 terms tells me that n is 20. My first term here is 8. My r value here, well, it looks like I'm dividing by 2 again, but if I'm not sure how to write that, again, I'll try 4 over 8 equals 0.5. Again, second term divided by first term. So I want to figure out what this is equal to. Looking for the 20th one. So I'm going to go, my first term is 8 times, the formula for it's up here if you're looking to see where I'm getting that from. So the first term, a, times bracket r, which is 0.5 to the power of 20 minus 1. Now again, that's not up in the power, it's down below. And all of that needs to be divided by r, which is 0.5 minus 1. And when we times this out, you will get 15.999. Again, don't round it too much there because we want to indicate here that it's not above 16 yet. So that's your formula for the partial geometric sequences. Sometimes you'll get really big numbers, sometimes you'll get a not too big number. It just depends on if r is going to increase it or decrease it. So just make sure you're plugging them in carefully to your calculator.